Okay, hello there, ladies and gentlemen. Let's talk a little about triangle congruency shortcuts. Thank you for taking these notes. That's helping a lot towards your understanding of the material, and will certainly help you on the upcoming assessments. So let's get to it. So we're kind of obsessed with this question, or at least I'm obsessed with this question. Hopefully you guys are too. I have these two triangles. I know that the basic information I need to prove is that all three angles that are corresponding in one triangle to the three angles in the other triangle are congruent, and same for their sides. So three sides and three angles is really what you have to prove congruency. However, luckily, we also have the possibility of doing some shortcutting. So this is something that we kind of stumble upon naturally, which basically says, well, look, I have these triangles. I don't know all the information about them, but I do know some. Like I know in these two triangles, I'm just going to draw down here. Please don't draw this with me, just watch. But I have these two triangles, and I know that I have three sets of sides that are congruent. Is that enough to assume the information about the other information about the triangles, i.e. the angles, are also the same? Is that enough to force them to be the same? So I posted this video before this, hopefully, that can kind of help you process through this. It's me using a template program talking through why we do have some that's enough, we do have some that's not enough, and how this really comes down to not so much the sides and angles, but actually the points. The whole thing, the whole argument really centers around these point locations. So even though I know that I have three sides on the left that are the same as the three sides on the right, I would argue side, side, side works simply because these two side lengths fix this point in place in the same way that these two side lengths fix this point in place. And lastly, these two side lengths fix this last point in place. So the side lengths actually force the points not to move. The points force the object to stay rigid, and so of course the angles have to be the same. So that's the kind of argumentation I'm going to look for in these notes. Okay, so there's some terms I'm using right off the bat that you probably need to pay attention to. The one term I'm using is corresponding. And when we talk about corresponding, all we're really talking about is that, and there's lots of ways to say this, you can summarize it as you want. When I use the term corresponding, I'm kind of talking about the matched pair. So specifically when I'm talking about, say, like triangles, um, it's the ones that look like they go together. And we'll expand the definition as we go, but that's good enough for now. Oops. So like if I have this point and this point, I would call them corresponding because they're both on the upper part of the triangle. They look like they're roughly maybe the same angle. Same thing with this one. I call the bottom left and the bottom left corresponding for the same reason. They're in the same relative location. Those are the matched pair. And I would call the green ones also corresponding for the same reason. They're both in the bottom right of the triangle, look like they match. You're going to hear me say this word a lot too. And a term I've been using, at least in the last video, quite a bit. It's a term fix. Fix is something that we talk about in math quite a bit, but when we talk and use that phrasing in math, what we mean is hold in place. Specifically, not to move. Okay. So like if I fix a location for a point, that means that point cannot move from where I just put it. It's in one place, it's forced there, it's held there, it cannot move. So again, if we think about what we're actually outlining in our notes, I would say that the question we need to ask ourselves are, what are the important terms? Necessary for understanding congruency shortcuts. Okay. So moving on. So those are terms I'm going to use. So the next question that would be the most natural to ask is, which triangle shortcuts work? Okay. So I said that kind of lengthily, but that's okay. These are notes, so we shouldn't mind kind of going a little overboard. So the question I'm asking now is which triangle shortcuts are enough to assume the remaining information is also congruent in both triangles? So in other words, which of those combinations actually is enough? So it turns out we do have a definite list. We have a works, doesn't work list. Okay. So we can just go ahead and fill this in. The working ones are side, 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 angle, and angle, side. I'll put an asterisk next to that one, and I'll explain why in a second. The ones that do not work are angle, side, and angle, side. Also referred to as side, angle if you don't want to write a bad word in your paper. So these are the ones that actually work. And we have to note that these combinations imply a definite order to the triangle. In other words, side, is actually linked information. In fact, it wouldn't be a terrible idea if you're not understanding what I mean, is to draw like a little arrow in between them. I used to do that quite a bit, um, just to remember that this information is linked. So what this kind of implies is that something like this um, is angle side, or something like this is angle side angle. That's a terrible version of that last one. Let me try that again. I'll try to mark the angle. Okay, yeah, that one's angle side. Oh, goodness gracious, I made a mistake. Do you see it? Can you guys please change that to angle? I think I just wrote angle side on that. I wasn't paying attention. I apologize, but I made a mistake. Can you please correct that for me? Make sure that doesn't work as angle. So now the question should be, well, why do some work and why do others work? Um, and so again, let me record that question. So why do some of these shortcuts work? Like why do these four in the left-hand column actually work pretty good? And why do the ones in the right-hand column not work at all? And again, I would say this comes down to um, a basic argument in fixing points. So let me record the response there. Okay. And I would say the ones that work okay, I would say fix points in place. The shortcuts that do not, do not. Actually, let me word that. The shortcuts that allow for multiple beginning triangles do not. Okay. So let's talk about some examples. Like, for example, I would say that angle side angle works simply because it fixed points in place. So angle side angle, that means I have a side in the middle, right? Then I have an angle coming off one side and I have an angle coming off the other, and those angles are fixed in place. In fact, let me change colors a little bit. So this angle is fixed. This angle is also fixed. So I can't change any of the information that I currently have drawn. These angles are known and cannot change. The side length in the middle is known and cannot change. It can't slide forward or backwards. So I would claim as of right now, these 2 point locations are well known. This guy and this guy. Those are known and fixed. Okay? And they're known and fixed simply because there are two lines that intersect to form that point. So what I mean is, this blue line and this black line intersect to form that point. Same thing on this side. Intersect to form that point. Because they have two lines intersecting to find a single point, that point has got to be fixed, mostly because I cannot change the other points around it. So I would say the third point is also likewise fixed, and here's the reason why. These have to extend out to meet a third point. Okay? So this point is also fixed because we can't change the angles. Okay? So because that point is fixed, that is literally the only triangle that I can draw. There is not a second triangle that's possible. So this is only okay? So that is the only triangle that I can make as part of this exam or using this information. That means that once I translated it or rotate or reflect it, it's going to stay the same triangle because they're rigid. So the argument is not so much for what a transformation does, because a transformation is like the vehicle. It's for what these shortcuts actually fix in terms of information for one triangle. If it's fixed to begin with and jumps in the car and transports across using, again, reflections, translations, or rotations, it's of course going to be the same triangle as it could, or I started with, excuse me. So the counterexample to that would be something like angle, 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 okay? Which I claim does not fix information uh, to begin with, so the transformation that occurs at the point doesn't make any, or doesn't really matter. So here's my kind of counterexample to it. Well, let's say I have this angle that's fixed, and I have this angle here that's also fixed. I can't change it. And then I have a third angle, let's use purple, up here somewhere. Okay, now you could say, well, Mr. Collins, you do have to make a triangle out of that. I totally agree. I can make a triangle out of this. But here's the problem. That's not the only triangle that I can make. Let me duplicate this. Whoop, copy, paste. Okay, so the problem is that this triangle exists in the same way this triangle exists with the same angles, um, but different side length. Also, we can go inside, same angles, different side length. So, even though the angles are fixed, these points are not fixed. Okay, if they're not fixed, that means I can make more than one triangle out of the same information. Okay. Oh no, my village is raided. Oh, there, Farmer Johnson. Thank you. Okay, so if I can make more than one triangle out of angle, 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 that means I can't guarantee once I've transported it, reflected it, you know, reflected, translate, or rotated it, that I'll end up with the same triangle I started with, simply because the points themselves had been variable to begin with. So the difference in the two side by side is the one on the left, those points are where those points are, and I cannot change them. I cannot move them around in the same way I can freely move around these 3 points, these 3 vertices, okay, because we're talking vertices here. I can freely move those vertices around simply because they're not set in a set location because of angle, 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 nor are they a set location because of angle, side, side. Now, again, if you haven't watched the previous video or the other video that comes with this, I encourage you to do so simply because um, that's going to be a big piece of the argument. Like, that's actually giving you a nice visual of why these points are fixed or not, okay? So like always, it's up to you to now write a summary of the notes. Again, the procedure for writing a summary of the notes is to choose 3 to 5 words or phrases that are essential to answering the essential question. Okay, and the second thing is to purposely use those 3 words or phrases in the summary. Okay, and also, like always, if you want to earn a couple extra Class Dojo points for this week, post your summary as a response to this video on Edmodo. Okay, so guys, that's what I got for you. We're gonna now dive into the wonderful world of proofs. Now that we have kind of a sense of what these proofs need to look like, and there you go. That's it. That's what I got. Thank you guys so much.